Good morning, Earth Science, and welcome back. Today we're going to talk about resources and the environment. This is chapter 7. So, what is Earth's environment? The environment includes all of the resources, influences, and conditions at or near Earth's surface. And when we talk about resources, we're talking there's two different types of resources here. The first, of course, is renewable resources. These are ones that can be replaced in nature at a rate close to the one that we use it, or they renew themselves faster than we're able to use them. These include things like air, water, some land resources, and sunlight. Other examples include things like the forest, things like soil, things like ice can be renewable as long as it's being replaced at a rate close to its use. Non-renewable resources, these are things that exist in a fixed amount in the world. We only have so much of it, or it's used up much faster than it can be replaced in nature. Things like oil, things like metals, things like minerals. Each year, it's estimated that each U.S. citizen uses 40,000 pounds of new material for cell phones, for cars, for things like this. So these are things that can't be renewed as fast as we're using them, non-renewable resources. For Earth's minerals, just remember that chemical elements can be divided into two categories, the metals and the non-metals. The metallic ones are the ones that are of greater importance economically. They're the ones we spend more money on for the most part. Some of them exist naturally, things like gold and silver, and some of them are combinations of elements put together. Steel is carbon and iron, bronze is carbon and tin, and brass is carbon and tin. Things like minerals or ore minerals, these are rocks that contain this valuable mineral, this metallic element in it that we call an ore mineral. Ore minerals are only the ones where if you separate them and separate the ore from the rock, it would make it profitable to do so. The rest of the stuff that comes with these ore minerals is known as gangue, and it's some common gangue is things like quartz and feldspar and calcite, and that makes sense because when we talked about minerals, we talked about how very common these things are in the crust. So it makes sense we're mining out these minerals that we want to get rid of these to get to that good stuff. Some other non-renewable resources, things that can be extracted out of the ground. For the most part, these are things that can be extracted just as they are, things like sand, natural gas, talc. We got salt over here, table salt. Things like gypsum here, sulfur, uranium, and then this other example here is coal being pulled out of the ground there. When we talk about these things, we talk about a certain amount of supply and a certain amount of demand. Every year we use a certain amount of resources. This is our demand for that resources. And every year when we mine or we extract things, we can only produce so much product. And this is the supply of that resource. This guy here has got a very finite supply of the sulfur that he's mining there. We also have to look at the availability of minerals. Reserves are a known deposit of a mineral in ores that's worth mining. So a reserve of gas, a reserve of salt, a reserve of gold, silver, tin. The cost of mining takes a factor here. If it's going to be really expensive, it's going to be harder for us to go utilize a reserve. If it's really, really close and to the surface, it'll be much cheaper to do so. Knowing how big a deposit is, a reserve is, and how fast it's going to be used up allows us to estimate kind of how long these reserves last and to kind of price into how much supply and demand that we need. As far as using minerals, we have large reserves of minerals, but we also use up minerals very quickly. So we need to import minerals or bring them in from other countries, things such as platinum, magnesium, cobalt, chromium, lots of other different minerals. This map here, the more red areas are places that we do lots of imports from, so places like China and Canada and Russia and Brazil. And then the white are less. We do lots from South America down here. So we're getting lots of minerals from these other different places and Mexico to supplement our minerals that we have here, because we don't have enough as a country to make enough for what we use them for. But why, especially for metals, why are they so important? There's a really high demand for things like iron, so we can make carbon, we can make nickel, we can make tungsten, because we like to make steel. Copper is used in electrical wiring and heating. This here is a picture of a car with all the copper wires in it. On average, cars have about 55 pounds of copper in them. Things like phosphate and nitrate we use for fertilizers so that we can continue to grow lots of plants, so that we can continue to feed our growing population. So metals are pretty important. Jumping into the next section here, we'll talk about energy resources. Things like water, things like wind, and even humans were able to supply energy for work. We also use these fuels to provide energy to run things. We used to use wood for a lot more energy and for heat and for steam power. But as a society, we've kind of moved away from that because it's kind of dirty. It takes a lot of work to harvest the wood and get it ready for that. And it's not as effective. It doesn't produce as much energy as other kind of methods do. So when we talk about non-renewable energy sources, 15% of our world's energy currently comes from renewable resources. The other 85% are from non-renewable resources such as coal and petroleum, natural gas, and then nuclear fission, which is this picture here, is another player in this. So a fossil fuel is any fuel that we're using that is formed from the remains of organisms that lived millions of years ago. Most of the time, these are made out of plants, things that are left over from the Carboniferous period, but animals also play in here. The burning of these fuels releases that energy that's stored inside of them. Usually they're trapped way down below the Earth's surface, so we have to go down to get them. Fossil fuels are non-renewable because we're using them up much faster than they're being formed. We're not forming a ton of new fossil fuels right now, and we're currently continuing to use them at a very high rate. The first here is coal. And if you're on the east coast side of the United States, this is still more common over there. But it's used primarily in power plants to generate electricity. Coal is an organic sedimentary rock formed from plant materials that have been squished down. As this material gets buried in swamps, it decays slowly. As it decays, it loses hydrogen and oxygen, and these are the constituent parts of water. So as it loses this more and more water, it gets more and more compact. So we take this lightly compressed plant mass, and it's called peat, usually made out of peat moss. As it becomes compressed, it turns into this soft brown coal we call lignite. And after millions of years in compression, that lignite becomes bituminous coal or soft coal. And then as it continues to get pushed, squeezed, and then heated a little bit through regional metamorphism, it can become anthracite or hard coal. And the hard coal is the more dense, more energy rich. And each time we go down this step, we're losing more of that hydrogen, oxygen, water to create this more dense version here, this more energy compact version of coal. So petroleum is next. Unlike coal, petroleum is a liquid. Both of these guys are what we could call sedimentary rock. Even though this isn't a solid, rocks aren't like minerals in that they have to be, there's a little more flexibility in the rules on them. On top of petroleum, we'll find things like natural gas deposits. And then when we actually drill down and retrieve the petroleum, we usually only retrieve about 60% of a reserve, and the other 40% is left in the ground. Our next non-renewable energy source here is uranium. They come in these little pellets. Uranium is most commonly used as a fuel. When we take these atoms of this isotope of uranium and hit them with neutrons, the atom splits. This produces a lot of heat. We use this heat energy to convert water to steam, which runs turbines to produce electricity. And in most of our energy sources, this is what we're doing. We're running these turbines to create this electricity that we then can pump out. Where do we find uranium? Usually recovered from this black mineral, uraninite, and this yellow mineral here, keratite. Using 1 gram of uranium releases the same amount of energy as using 14 barrels of oil, so it's a much more compact energy source. The downside to nuclear power is the waste of it takes about 1,000 years to neutralize and is really not good for anything it comes into contact to that's alive. So since we had non-renewable energy sources, we also have renewable energy sources. Those are the ones that can be replaced as quickly as they're used. Some examples here are things like water, wind, solar, geothermal energy, hydrogen, if we figure it out. Um, all of these are good examples of biomass, like burning wood for heat, are examples of renewable energy resources. The first is water, and we use water to produce electricity. We use this hydroelectric power. Um, this electricity produced using water is really efficient because the turbines that produce the energy are directly turned by the water. There's no converting to steam or any of that other steps. Um, so it doesn't have to be converted to steam like with coal or uranium or natural gas or any of that. Tidal energy. This is a fun one. We're working on making this actually usable. But as the Earth's oceans rise and fall, that is a lot of energy being used there. So what we'll do is we'll trap water behind a barrier at high tide and then release it at low tide. And as that water spins this turbine, it produces some energy that then can be used. Wind energy. This is kind of whenever I think of renewable energy, I think of like solar and wind are my two big ones. But this is things that we're capturing wind. It's either captured by a windmill or a turbine. You can see these blades on these guys are really long. This is a guy there, an adult man. The adult power that these guys can generate depends on the speed of the wind, how long these guys are, the efficiency, if it's an old windmill, a new windmill. But they also take up a lot of space. These guys take up a lot of area. You're gonna have to make these big wind farms to make it worthwhile. Solar energy. We use solar energy for not only electricity, but also for heat. So we can either use passive or active heating. Passive is designed to collect and store solar energy. So an example here is like these tires here are collecting and storing energy, or inside of these tubs at the bottom here, they have big amounts of water. This water heats up during the day, and then during the night, it releases that heat to keep everything really nice in that greenhouse there. So active solar heating, on the other hand, has three parts. It has a solar collector that faces the sun, a storage area that's storing the heat, and then a system that's distributing this throughout the building. And in this system here, they're pumping cold water out through these solar collectors here, which heats up that water, and then that warm water returns to the house and heats up the house. So they're using, this one's not for electricity, this one's actually just for heat. We also like to use solar for electricity. Things like this solar tower here, all of these around it are mirrors that are reflecting light up onto that tower so that it can collect it and then condense that solar energy. We also use solar cells here to generate electricity both on Earth, but a really exciting application of this is we use it to power most of our satellites in space. So very exciting application there. The next one is geothermal energy. This is using heats from the interior, where we take this highly pressurized steam and we heat pipes that bring that heat back up into the house. So this cold water is pumped down, or it goes down with gravity and then pumped back up as hot air. So yeah, we're using the heat inside of the Earth, the geothermal heat, actually to create some heat and energy here. Most of these sources are drilled on top of natural gas, and so we end up getting both of this heat energy and the natural gas. So pretty clean energy. We can use geothermal for power here. What we'll do is we'll take and we'll drill way down and we'll pump cold air all the way down into this reservoir, which gets heated, and then that heat comes back up as steam or hot water, and then it's either used as heating or cooking, or it's used to spin a turbine and make electricity. And in places like California and Iceland, where they have lots of geothermal, this is really commonly used. So there are some environmental issues when using Earth's resources. We all often damage the environment on either mining them, or we get things like pollution or global climate change. There's a lot of trash here, you can see. The problem that we have with our lifestyle is that we have a lot of disposable things that don't get reused. When we mine, we remove tons of soil, tons of ore, tons of rocks. This creates these rocky environments where life really can't live yet because there's no soil. But it also produces lots of waste rock, and then any water that comes into contact with this can become contaminated and become poisoned. So it's not only the ground that's not conducive for life, but now also the water's not. Some bad downsides here to using uranium. Uh, these nuclear reactors make very dangerous radioactive byproducts. Like we said, they can't be around living things for thousands of years. But you also run the risk of really bad accidents with uranium. We've gotten a lot better, and the fear here has gone down a lot. Unless we get like an earthquake, like in the Fukushima accident, for the most part, nuclear has become pretty safe. But the classic example here is the Chernobyl power plant, where we had 32 people die, thousands become ill, and millions of acres contaminated with radiation. So there is some risk here, and so that's why we like to put our nuclear power plants kind of away from large populous centers. And additionally here, as we burn fossil fuels, it creates some negative effects. We release these pollutants into the air. This can mix with water in the air to form acid rain. These trees here have been hit by acid rain. They've lost all of their foliage, so they are now losing, their leaves. But acid rain also can damage buildings, it slows growth of plants, it harms crops, and it can kill plant and animal life in streams and rivers. Specifically, our amphibians, things like frogs and salamanders, are really, really vulnerable to this kind of thing. So, renewable resources, even though renewable resources are less damaging, they do have their limits. They're not all usable everywhere. So, like things like water power isn't extremely useful in the desert. Things like wind power is hard to store. We don't have really good batteries to store wind power. And so when the winds are slow, these areas lose power and are not able to create it. Something that's become more popular and something that we've talked about more is conservation, which is the protection, restoration, and management of natural resources. It doesn't mean we stop using that resource. Instead, it means we develop ways to make it more efficient or develop ways to make it more like a renewable resource where we're using it at the same rate that it's coming back. So things like good conservation are things like planting trees, preventing topsoil erosion. We'll mine it we'll take it off before we mine somewhere, and then when we're done, we'll put it back so that this area still has soil so it can still grow plants. Very cool. Humans, we've kind of started to figure out recycling, where we can collect and reuse materials from waste. Things like e-waste and things like organic waste, I think, are some things that we don't really think of as recyclable, but are. So we can recycle things like aluminum, iron, gold, computer chips. We can use it to recycle glass and paper, which are made from renewable resources. Mr. really likes upcycling, or this recycling where you take something that was old and then you kind of fix it up so that it's new now, and then you continue to use it and you don't let that go into the landfill. I like that kind of stuff. Personally, we've made some laws regarding environmentalism since the 1870s, and specifically we started to pass some federal and state laws to protect the environment. The EPA came out in 1986, and it is to monitor and set standards for drinking water and air quality, but it also is responsible for controlling the production and disposal of toxic wastes. So making sure that we don't we're not have a factory that's dumping waste right into the river right beside it, that they make sure they dispose of that in a proper manner. Another legislation here was the Pollution Prevention Act of 1990. It was designed to control pollution and conservation of energy, water, and other natural resources. This one included emissions from automobiles, sustainable farming practices, and that companies should use recycled products. It kind of had this model here where it wanted to reduce the use of sources and then recycle them. And then if they couldn't recycle, they would do energy recovery. And if they couldn't do all that, they would the treatment of these things to make them less toxic before they disposed of them. And then the least preferred method here was to dispose of these things, but still in a safe manner. So this concludes chapter 7. I hope you learned something. Thanks for watching, and we'll see you in the next one.